Hello everyone, and today I'm going to show you a CA3 that I've done for my final project for functional programming. I've decided to do the game on BlackJack. There are some rules that are here, so you can read them if you want to. The basic rules, I will be following them. There is a text file for the rules, and it does load that in. So first we're going to go through the code. I'm going to show up the file that's going to read in all those rules that I've used. This is just for comments on the code, and then we'll see a couple of games that run, and we'll work through what happens during the code here, and then I'll show a few of the runnings of the game. Alright, so in BlackJack the cards 2 to 10 are worth their respective endpoints. Ace is worth 1 or 11. I've decided to implement this using an algorithm that uses the 1 and the 11, and it's using by the sum of all the cards. The dealer will draw their own cards till they get to as close to 21 as possible, and it does not draw if they're already over 17. That's the rules written here, 17 or greater. That means the dealer draws there, the player chooses to hit or stand, and the default is they will be given the 2 cards start, as they traditionally are, and they choose whether to hit or stand. Stand will equate the current totals. Hit will give them a new card, and only when they say stand will it stop. Now they can go bust, or the dealer will go bust, and it will stop at that point and award the sum of the bet to the player. So the goal is to get to say they put 20, they will be given 10 out of 20, and they can bet up to 10, but they can't bet less than 1 for each game. So when they win, it goes round and round, and it only stops when they've lost all their money or they've got to that total. They can get above the total because they could bet more, and it actually just prints that out before it stops. So BlackJack will also pay out 1.5 times what they bet to the player. So I've basically created a card enum type, which just takes all the totals. Now for the deriving we show, because we want to show the card, it's an enum type. It's bounded during a min and a max value, 0 to 12, and the read, so that we can read up some values from the respective value for the calculations later. Now it will show A, J, Q, K, and my show function will actually show the number 2 instead of TWO, so it looks single symbols. I'll show that later. Let's just go down to some of the functions. I've used draw dealer cards. It takes in a standard generator, an integer, and some cards. So the total is the integer. This is how it knows what total the cards are worth on each check. So the guard function has, if the total is lower than 11 and the random number is 1, then when we 2enum minus 1 of the random number, the number generated 1, that's obviously an ace. If they're under 11, we can count the ace as either 11 or as 1. This is how it determines what the ace is worth. Is if the current number is valued at less than 11, which is 10. If you count that as 11, you get 21, which doesn't bust. So in that case, you can do it. If it's above 12, they'll go bust if you count it as 11. So all you do is you keep the number, but you add 10 to it if we're going to make it worth 11, because it's 1 here and 10 here. And then the total is under 17 is when the dealer stops to draw. So if they're under 17, we try and draw a new card. And then the total is increased by that number, so it knows to stop when it checks total again for the cards are drawn out to 17. That's how a dealer normally works in the game. They don't stop until they have 17 cards. And otherwise you put in an empty list, which gives you the list of cards stops at the blank list. And this is just your generator between 1 and 13 for the cards we want, which is why we minus 1 off this one, because they were obviously between 0 and 12, so I just did it this way around. So when you do the start player cards, this is how the player starts. I have a stop. Maybe there's a better way to have implemented this, but I put a 2 on it, and you take 1 away, and that gives you 1 card. And then when it's not equal to 0, it gives you another card. So stop is 2, gives you a card. Stop is 1, gives you a card, and then comes back with a blank list. Same random generation number is used there. Drawing a player card is when they choose to hit. This will be called. And I generate a generator and I put it in. And then I return a list with just 1 card. And then I concatenate that to a list in a let later on that you'll see. I can't just generate a single card because it won't let me add it to the list for some reason, but this was fine. So I just add what cards do you have plus the card that's in this list. Use a generator there as well. Hand value gives you the cards and it gives you back a list of ints. When it's at the end, it adds nothing to the ints. So for each card, we get the enum value, and if it's under 10, then that means that it's Jack, King, or Queen, and 9 will be a 10 in the cards. So they're worth 10 points each. So we only want to count it as 10. So that's why we add 10 to the list of points, because the Jack is also worth 10, Queen and King are worth 10. And then otherwise, you take the enum and we add 1 because the enum will be 0 plus 1. So that's how you will get the ace. Is the from enum of an ace will be 0 plus 1 is 1 point. This will be equated again later to compensate for the ace if the value is under a certain amount. I'll show you that one later on. I was thinking of putting these into a module, and I have a module to show, but I couldn't load it in for some reason. Some of the functions wouldn't be detected when I imported. It's probably something to do with the way that I'm using it. It's like in WinGHCI, I would use the import call and then I could use the functions, but this, it just wouldn't load after I'd done it inside the file here itself, so I'm not too sure about that, but I'll show you the module just real quick at the end. Show cards will show the actual cards out as a string. Show cards of the empty list will just be no string. For each card, get the from enum, and if it's smaller than 10 and the enum of C is smaller than 0, that means that it's not an ace and it's not a Jack, Queen or King. So I would actually show the number. The actual number would be shown instead of the actual card TWO, THREE. It'd just be 2, 3, 4, 5, 6, 7, 8, 9. And it's concatenated again with a comma, space. Maybe a space would have been a little bit better, but I decided to do it this way. And then you call the cards again on CS until you get to a blank list, just returns blank. Otherwise, you can just actually show the literal card, which means that it won't fall within being an ace or a Jack, Queen or King, and the comma again. So you'll just see, say, 2, 4, 8, Q, K, A, stuff like that. And that's how I altered the card type up here, because I can't put numbers into this enum. So that's how I got around displaying it that way. Okay, so after that we have the hand display, which is it takes a list of cards and gives you a list of ints. So what this does is for each empty list, right, you take the C in, you take from an enum C up 1, that gives you a number that you concatenate on. That gives you the total list of all the points of the cards. That's like how much the whole hand is worth. And then display a card is a list of ints and gives you back some cards. That's to translate the points when you first have them into a list of cards to show that the other equation uses up here to show the cards on the screen. So for each x in excess to an enum, you take the x value, take away 1, because we remember that enums start from 0. So whatever the point value is has to go down 1 now this time. Like here it had to increase to get the points. This goes down. It's just for transferring back and forth between cards and points and cards, you know. And then you concatenate it with the rest of the list. Empty list is empty. Now this is some cards, which alters the amount of the cards if they're less than 12. There must be an ace in it, obviously. So what we're doing is we sum up this list of cards, as you can see in the otherwise, but this is here for the ace. If the sum of the cards comes out as less than 12, and maybe this is a bit redundant, but just checking that it's under 12, and the 1 is an element in the cards, that means we've got an ace. So the fact that it's actually under 12 in value would mean that it's 11, which means if we count the ace as a 10, we get to 21. And that's how I convert the points back up from earlier, where I counted it in the total as plus 10 in that recursive function that I have earlier up here, as you can see there. Now, the point total is actually going to give back a string. This is used in stand and in all the equations of the main game to see who won. What we're doing is the value of the hand of the dealer cards, that gives you the list of all the points the cards are worth, and then I sum it up. I do the same for the player cards, and we're checking if they're exactly the same. Then the game draws, because I have a function that will check if they've already bust. If they haven't bust, obviously we're going to do hit or stand, and it tells you if that function point total player cards point total dealer cards player cards is actually what I have in my main game, and it will say if it's equal to game draw, you lose, you win. Then obviously I have the logic in there to equate out what the bet is and to print out whether they won or lost. And that's all there is for my helper functions. Maybe there's a few more I could have done here. You should see there's a lot of else and else and if else do in here. Maybe this isn't the best way of doing it, but this it does work. However, it could be really tidied up quite a good bit. For the main do, what I do is I begin to say enter in your balance, you'll get half, minimum is to have a 20, taking a line. This is only one problem that I couldn't encounter with the limitation is if they entered in any text. I tried to use read s or reads. I wasn't sure what was going on with the art. It wouldn't allow me to validate, so what I did was if the read of the balance, right, so you read it, you get an error, you get a parse error. So I just try and just enter numbers for now. It's something I can fix later. But if trying to read the balance in as a double, if it's smaller, well, a double is needed because I'm going to divide by 2 later. But if it's bigger than 19, then we're okay. Otherwise, we haven't entered a valid balance, and it's game over for them. Okay. So the balance has to be greater than 19. That prevents it being 0 as well. So it has to be at least 20 up. So you could get a decimal there, but I have a check to see if it's just less than 1, which kind of eliminates any kind of problems with letting the user bet with a single integer number. It just will let them lose because obviously they didn't enter a valid number. Could have checked if it was even, but it would have been a bit more overhead to this. So what I do is I call the menu and I read in the double and I half it. That's the current balance, and the target balance is just the actual number itself. This will give them, say, if they enter 20, they'll have 10 points to work with. And same on for any number they've entered in. Main will now run again if they didn't enter the right thing. Otherwise, the menu below will run. Now, once the whole game is finished, it'll say game over because you've lost all your money or you've won everything and you've won the whole game. It'll say type yes or no, and if they type yes, we just go back through main again. That's the whole lot. The whole game again runs and then it finishes, and that's it. If they say no, then thank you for playing. Otherwise, we didn't understand and we still exit anyway. That closes up the introduction to the main. The next part I will explain the menu and then going down into the game. So now we're just focused purely on the introduction menu and the game playing mechanic itself. Alright, thank you, and I'll see you in the next part.